Now, let us look at some of the examples of control systems. So, we will see first example, a very simple example, that is a bread toaster. All of us, or at least some of us, will know we use the bread toaster. Now, look at what is this bread toaster is. The objective here is to have the desired color of the bread piece. Now, how do you get that? So, usually in bread toaster, we have what is called the timer. So, we are going to fix the time. So, based on the time, then we are going to have the color of the bread. So, we can look at this. This is a timer. Let us say I have a different variations of timer settings and respect to its colors. But we know that the color should be in an ideal, that is like light brown color to have the better toasting of the bread. Okay, that we know. That is a desired. Now, so if we model this system, how can you model this? We do some experiments. So, depending upon the time, that means we vary the time, we fix the timer level, so it is a 2, 4, 6 and see what will be the bread color here. And we fit one particular curve characteristics and from that we can model it. Now what are the disturbances generally coming? When you fix the timer, then depending upon the bread type, we don't say that always we use the same kind of bread, depending upon the bread type and also whether you put the cheese on it or it's a plain bread, then you are going to get the color. Then if you want to have a particular color, then when you vary the bread type, if the timer is fixed, you are not going to get the objective here, you are not going to get the desired color. So these things generally we call as disturbance. Now how can we do in terms of control perspective? What is the open loop control? In open loop control, this is the bread toaster and we give the input as a timer level. So time is the input and the output is my bread color. But whenever you have disturbances, yes, the output color may change. The objective is not reached. Then what we can do? Look at the closed loop case. So in closed loop controller and the human being interference is there, which means you be there and observe the color of the bread. And if that is satisfied with the desired color, you know what is the desired color in your mind, then there is a button on off controller, then you just keep pressing on. If it is desired, yes, you just put it off so that you are going to get the bread and put one more bread, then you on it and see the color and do it again. If it is reached, when you get the desired color, then again you switch off it. So this is kind of a closed loop control where human interferences always be there. Next, when you look at the summary of this bread toaster control system, what is the plant in the system? Plant in the system is a bread toaster. What is the reference? Is a desired bread piece color. What is the output? The actual color of the bread piece. And what is the controller? The controller is nothing but the timer or the on off button what we use there. What is the control action? Yes. So we have the toaster on off button and that is operated by the human being or you or me. And what is the disturbance? Disturbance, sometimes the timer may failure or there may be some change in the bread piece or whether it's cheese or plain bread, and all those things are disturbances to the system. And what will be the feedback? And we are there to monitor it. Therefore, the monitor the bread color by the human being. So these are the components in any control system, and these particular examples and the respective things we have shown here as a summary. Let us look at another example. See, you are at the office, you have to go to a house because there is a function, the bode function, right? You know the distance and based on that you can calculate, yes. So if I go with the speed of 50 km/h, then I can reach my destination, the desired point of time. Now the objective is to maintain the speed of the car at 50 km/h. Now, so when you look at the open loop case, this is the car, we can model it of course. Now your controller is nothing but you will have the accelerator and you are going to pedal it. And I am going to give a constant force on the pedal of the accelerator. When you give the constant pedal and the output is the actual speed and you know the input speed. So this works well because you are maintaining, you know that how much force you need to apply to get the 50 km per hour. So you press this and it works well when there are no disturbances. But there will always be disturbances in this particular system. The disturbances are nothing but you have weather conditions, that means you may have a wind or you may have rain, or sometimes the road conditions, you may hit the upslope or downslope, sometimes there are speed breakers and all those things. These are nothing but your disturbances. So when you have these disturbances, if you maintain the constant acceleration, constant force on the pedal, then you cannot reach the destination in time. So your control system, open loop control, may not perform well when there are disturbances, as we know. Now how to make it closed loop? Right, one way is, so in your car, when you are driving the car, you have a speedometer. You can look at the speedometer. That is going to be the feedback. Now this is the car model plant, and I have the actual speed. You measure the speed using your speedometer. See the speed, and in your mind you have what should be the desired, that is a 50 km per hour. Now your brain is acting as a controller. You know what to do with this. Is a positive error or negative error? We need to increase the speed or decrease the speed. So based on that you are going to you pedal your accelerator. So when there are disturbances, let us say you have upslope, then we need to have the more force on the pedal to increase the speed, to maintain the speed at 50 km per hour. Okay. So when there are speed breakers or when there is a wind, so for all these conditions your brain will act as a controller and it will take appropriate action, and you are going to have the proper pedaling and the accelerator, so that your car will always drive with a speed of 50 km per hour. Now, so when you look at the summary of this, driving a car by a human being, what will be the plant? The plant is, of course, it is a model. What is a reference? And you know that it is a desired speed, and actual speed is your output. Your controller is your human brain, right? It is a human control, and control action is a force applied on the pedal, and the disturbance, we know the road conditions and weather conditions. And what is the feedback? The feedback is we are going to monitor the speed by human eyes, that is nothing but your speedometer. Now what happens, let us say you forgot your spectacles, so you cannot see the speedometer properly. You can see that it is in between let us say 40 and 60. Now if that is the case, you don't know whether the car is exactly it is 50 km per hour or it is less than that or just above that, but still you are able to maintain it. And this particular thing we can call it as in control system is a noise, especially it is a measurement noise, because the sensor, the measuring system will also have the noise. Okay, and your controller has to design such that it will take care of this kind of noise also. Now I don't want to use the human interference in this particular system. I want to make it automatic. That's what we are looking for in general. So driverless control. What is the driverless control? So we have the car, yes, and we have all the disturbances. Whatever the disturbance we have, we are taking care of that. And you have a sensor that is a measuring speed of the car, and this sensor is compared with the desired. You also have the desired. Now I am designing a controller. It can be a microprocessor or any PC based controller, any kind of controllers. Very advanced controllers are coming to picture. So any kind of controller we can design here. Then this particular controller will give the input to the actuator, and this actuator will actually drive the accelerator of the system, so that the car will go at a desired speed, which is called 50 km per hour.